Alright, today I want to talk about how to add fractions. So what I've done is I have split this into three parts. In the first part, we will look at how to add and subtract fractional numbers, and I'll do this with two different examples. And because oftentimes if you happen to be a teacher or a smart student who is interested in knowing why this method works, I have given a small proof of the method as well. It's not obviously a formal proof of any kind, but it's good enough to convince you that yep, this method should work. And finally, I'll show you how to add and subtract algebraic fractions, what people call as rational expressions. And without much further ado, let's get on with this. So my first example, like I said, is going to involve adding fractional numbers. For example, if we have 5 over 6 plus 7 over 8, the first thing you have to do is find the LCM of 6 and 8, and that LCM is going to become the common denominator for this fraction. Okay, and to find the LCM, I know a lot of you, just one look at it, you will say, yeah, 24 is the LCM. But for the benefit of those who don't see it that clearly, or if the numbers happen to be somewhat different, here is the idea. Write down 6 and 8 on the side, go to the side, do this. Now ask yourself, is there a number that goes into both 6 and 8? If you can think of the biggest number possible, that's perfectly fine. So in this case, I'm sure you agree, 2 goes into both 6 and 8. 2 goes 3 times and 2 goes 4 times, right? Now, is there anything that goes into 3 and 4? Nope, other than 1, nothing goes into 3 and 4. So you stop at that stage and you simply multiply all the outside numbers. That is 2 times 3 times 4. And that gives you 24. So 24 is the LCM. Now, the next important thing to do is put an equal sign and put a big bar. I think this is where what I try to teach is something slightly different from how you probably learned how to add fractions. Okay, put a big bar and write down this common denominator, the LCM, under the bar. And then you ask yourself this question: what is the common denominator divided by the first denominator? That is, go to the side. You don't have to be macho. So go to the side and figure out what is 24 over 6. The answer is 4. Right? So take that quotient 4 and multiply by the first numerator. That is 5. Okay, let me repeat that. Common denominator over the first denominator, 24 over 6, and that equals 4. Take that quotient 4 and multiply by the first numerator, which happens to be 5. Okay, the next thing is we have an addition going on, so put a plus and do the same thing for the second fraction as what you did for the first one. That is, go to the side and figure out what 24 over 8 is, and that happens to be 3. Take that quotient 3, and this time, because we divided by the second denominator, use the second numerator to multiply this quotient with. Okay, and it's just a matter of simply multiplying this out, and that equals 41 over 24. As simple as that. Okay, so now let me pick another example. This time I'll pick 3 fractions, such as 3/8 plus 5 over 12 minus 7 over 18. Aha, we got 3 fractions and 3 different denominators. So as before, let's try to find the LCM of those three numbers, 8, 12 and 18. Now, is there a number that goes into all three of them? Well, 2 does. 2 goes 4 times, 2 goes 6 times, 2 goes 9 times. Is there any other number that goes into all three of them? Answer is no. Okay. Is there a number that goes into at least 2 of them? Well, 2 goes into 4 and 6, right? If you saw that 3 goes into 6 and 9, perfectly fine. But let's take this 2 going into 4 and 6 for the time being and say 2 goes 2 times and 2 goes 3 times, right? Now what do we do about the 9 into which 2 does not go? And here's the trick. You simply copy it down. Don't do anything with it. That is, do not say 4.5 or something like that. Just write down the way it is. At this stage, now once again you ask the question, is there a number that goes into at least 2 of them? Well, 3 goes into both 3 and 9, right? So use 3 to divide all this time. How many? 3 does not go into 2. Well, because of that, just write it, copy it the way it is. 3 goes 1 times, 3 goes 3 times. Now, is there a number other than 1 that goes into at least 2 of them or all 3 of them? Nope. So we stop at this stage and we multiply all the outside terms. That is 2 times 2 times 3 times 2 times 1 times 3. 2 times 2 is 4, 4 times 3 is 12, 12 times 2 is 24, 24 times 3 is 72. So, because I need room, let me come down here. Put a big bar as before. Putting the big bar is a very important thing. Okay. So 72. And do you remember the procedure that I mentioned? Figure out what the LCM over the first denominator is. Okay, and that's 9. Now, let me take a small detour here and mention something important. Notice how I phrase this. I say, figure out what the LCM over the denominator is, right? Figure out what 72 over 8 is. Oftentimes in America, the way we phrase this is, boys and girls, 8 goes into 72 how many times? Yes, on purpose I'm not phrasing it that way. On purpose I'm phrasing it as 72 over 8. And there's a reason for it. It'll become, will you please have a little bit of patience when I get to my example with algebraic expressions. You will see clearly why I say, do not say 8 goes into 72 how many times. Do not think along those lines. Instead, think along the lines of what is 72 over 8, which you can work out on the side. Okay? Alright, sorry about the detour. So take that 9, the quotient, and multiply by the first numerator 3. There's an addition going on, so put a plus. Do the same thing, similar thing with the second one, that is 72 over 12. And that happens to be 6. Take that 6 and multiply by the second numerator, which happens to be 5. And here the third fraction is being subtracted, so be sure to put a minus sign here to indicate subtraction. And 72 over 18 is 4. So take that 4 and multiply by 7 equals, put a big bar again, 72, 9 times 3 is 27, plus 30, minus 28. 30 minus 28 is 2, 27 plus 2 is 29, and the answer is 29 over 72. Okay? Now, teachers and other kids would like to know, why does this method work? So this may be a little, if you find this a little difficult, don't worry about it. This is only for those who are interested in stuff like this. Here is the idea. Suppose we want to add two fractions, n1 over d1 plus n2 over d2. In this procedure, what am I saying? Find the LCM of d1 and d2, right? The denominators. Let L be the LCM. Let L equal the LCM of d1 and d2. Now, what does the procedure ask you to do? It says find L over d1 and multiply by n1. So basically we would put a big bar, which is, and write the LCM, and then we do L over d1 and multiply by n1. Similarly, we do with the second fraction L over d2 and take that quotient and multiply by the second numerator, right? Okay, now as you can see, we can factor out an L out of the numerator, and if we do, we end up getting n1 over d1 plus n2 over d2 all over L, and surely the L's cancel, and this gives us n1 over d1 plus n2 over d2. So that is precisely what our problem was, right? And what is n1 over d1 plus n2 over d2? And our procedure says whenever you see n1 over d1 plus n2 over d2, do this. And so we have shown that in fact this is equal to the original problem. So our method is a valid one. Okay. Now, what about slightly more complicated fractions that involve algebraic expressions? For example, how would you add 3 over 4a cube b to the negative 2 c to the 4 plus 5 over 6a square b c to the negative 2. Cool. Is that complicated enough? Let's handle this one. Okay. As before, the first step is to put an equal sign and a big bar. And we are about to find the LCM of the two denominators, which is going to be our common denominator. Okay. We got 4a cubed c, b to the negative 2 c to the 4 and all this. So let's ask a simple question. With the numbers 4 and 6, what's the LCM? That's easy to find. It's 12. If you have difficulty, go and do the method that I suggested earlier. 2 goes 2 and 3 times, so 2 times 2 is 4, 4 times 3 is 12. Yep, the LCM of 4 and 6 is 12. Now, in the first term, we see an a cube. In the second term, we see an a square. When it comes to LCM of two quantities like that, a cube and a square, which have the same base, pick the one with a bigger exponent. Okay, so a cube has 3 as an exponent, which is bigger than the exponent 2. Similarly, when you see b to the negative 2 and b, understand that b means b to the 1, right? So 1 is bigger than negative 2, so we'll pick b as the LCM of b to the negative 2 and b. Similarly, c to the 4 and c to the negative 2, I'm sure you agree, c to the 4 is what we should say. Okay, what's the next step? Find what 12 a cube the common denominator over the first denominator is? Go to the side and figure this out. Okay, now let me remind you. Would you agree that in a case like this, it would be so hard to phrase this as, boys and girls, figure out what 4a cube b to the negative 2c to the 4 goes into 12a cube b c to the 4. You would say, you gotta be kidding me, right? So that's the idea. So make it simple and consistent for yourself. That is, always say, what is the LCM over the first denominator? Okay, and here 4 goes 1 times, 4 goes 3 times. We have a cube and a cube that cancel each other or divide each other into 1, and c to the 4s cancel each other like that, and this is going to be 3. What's up with the b over b to the negative 2? Now, do you recall that there is a law of exponents that says a to the m over a to the n is a to the m minus n, right? So according to that, this should be b to the 1 minus negative 2. 1 minus negative 2 is 1 plus 2, because subtracting a negative number is the same as adding the positive number. So instead of subtracting a negative 2, we'll add positive 2 to 1. So that makes this 3b cube. Take that 3b cube and multiply by whatever is on the numerator, which happens to be 3. Right. I want you to notice the consistency of the procedure. It's the same thing that we did even when we had numbers. Okay. In the next part, let's do the same thing with the second fraction, that is 12a cube b c to the 4 all over 6a square b c to the negative 2. 6 goes 1 times, 6 goes 2 times. B's cancel. We have 2. A cube over a square is a to the 3 minus 2, which is a. C to the 4 over c to the negative 2 is c to the 4 minus negative 2, which becomes c to the 4 plus 2, in other words, c to the 6. We have an addition going on, so let's put a plus. 2ac to the 6 is our quotient, and multiply that by 5. And so we got 9b cube plus 10a c to the 6 all over 12a cube b c to the 4. And that's the answer. Let me point out something very interesting and very important. I have had many students who make this mistake at this stage. That is, they want to cancel this. Hey, I see a b cube here and a b here. Can I cancel them or reduce that to b square? No. You cannot do that. That is because, notice on the numerator you have two terms. That is, one term is 9b cube and the other term is 10ac to the 6. We call them as two different terms because an addition is going on, something plus something. So that makes this two different terms. And the one in the bottom is what is the common denominator. So it's a denominator of the first term 9b cube, and it is the denominator for 10ac to the 6. So if you cancel or try to simplify this b cube with this b, this second guy will complain, hey, wait a minute, how could you do that? He is my denominator too. Right? So do not try to simplify anything beyond this one, not at this stage, or at least not for this problem. Okay? Now let me pick a last problem. This is going to be 2x over the quantity x minus 1 cube times 2x plus 1 squared minus the quantity 3x plus 2 all over x minus 1 squared times 2x plus 1 cube. Right? That looks pretty complicated. It's actually not complicated at all as long as you follow this method in its exact same way. Put an equal sign, put a big bar, and figure out what the LCM of the two denominators is. There's a x minus 1, the quantity cube in the first denominator, this one, and there's a x minus 1, the quantity squared. Well, like I said before, pick the one with a bigger exponent. X minus 1, the quantity cube. We have 2x plus 1, the quantity square, and a 2x plus 1, the quantity cube. Again, pick the bigger exponent, 3. Okay? As before, find the LCM over the first denominator on the side. If you can do some of this stuff in your head, great. But if not, there is absolutely no need to feel shameful of the fact that I cannot do this in my head, I better go and write it. That's perfectly alright. X minus 1 cubes cancel, and we have again 2x plus 1 the quantity cube over 2x plus 1 the quantity square. It is in the form of a to the m over a to the n, which is a to the m minus n. So this simply becomes 2x plus 1 to the power of 3 minus 2, which is 1, and so 2x plus 1. As before, take that and multiply by the numerator 2x. Now there's a subtraction that's going on. So put a minus sign and do the LCM, the common denominator, over the first, over the second denominator. And these two cancel, and we have x minus 1 cube over x minus 1 square, which is x minus 1. Right? Take that. Let me do something here on purpose. Oh yeah, x minus 1 times 3x plus 2. Is that right? Did I actually multiply? If I write like that, x minus 1 times 3x plus 2, have I really multiplied the quantity x minus 1 with quantity 3x plus 2? No, I did not. So we have to be extremely careful to put these stuff in parentheses so that there is absolutely no confusion. We are multiplying the quantity x minus 1 with the quantity 3x plus 2. So use these parentheses and square brackets and those kinds of things generously to avoid any misconception. Okay? Any confusion for yourself. Let me phrase it that way. And in this case, the question comes, could we simplify this any further? There's nothing wrong with the answer that we got. We could, some teachers would let you just leave it like that. But I think it's possible to distribute this out and simplify this a little bit. Okay, so let's multiply 2x with a 2x plus 1 or 2x plus 1 with a 2x. Would you agree you get 4x squared plus 2x minus odds? This is the idea. Whenever I'm about to subtract something, my antenna goes up. So I just go ahead and instinctively open up a square bracket or parenthesis, because I know I am going to have a whole bunch of terms inside this one. So x times 3 is 3x is 3x squared. x times plus x times 2 is 2x minus 3x minus 2, right? And in the next step, I'll patiently write down the denominator. And we have 4x square plus 2x minus 3x square. 2x minus 3x is negative x, and minus, we are subtracting a negative x, so I'll change that to adding a positive x. And similarly we have minus negative 2, so instead of subtracting a negative 2, let's go ahead and add positive 2. And I'm sure you see that this simplifies to 4x square minus 3x square. Collect the like terms. 2x plus x is 3x, and we have it 2. Cool. That's all there is to it. I don't know if you noticed what the numerator is. It turns out to be x squared plus 3x plus 2. If you want to, you can actually factor that and write it this way. I really don't know if your teacher would expect you to do that. If they do, you know what to do. Fine? Alrighty.